Have you ever wondered how the AI slop you see on YouTube gets made? Have you wanted to learn different use cases for generative AI? Do you want to become a better programmer? Today I'm going to show you how that AI slop is created with a really cool project I built last winter. This will be a great overview of how this works, and I'll follow up with future videos on how the actual individual components work if this does well. Hi, I'm Blex. I'm a data analyst by trade. I like to tinker. I'm curious about technology. I'm definitely a hacker, not a professional software engineer, but I'm super interested in all this AI technology, and I'd like to showcase a project today that actually started back in 2017, but has been really enhanced by the latest LLM technology that's available to us. I will caution, subscribe at your own risk. I only post on great occasion when I feel like it, so take that risk if you want. What is this project? It's an end-to-end video production tool. It sources information, it organizes the information, it generates images, it converts text to speech, it strings all of that together into a video, and packages and uploads that into YouTube.
A Dyson sphere is a hypothetical megastructure that encompasses a star and captures a large percentage.
And it generates all these different titles that you're seeing on your screen here now, including the individual thumbnails, as well as all of the tags and metadata that goes along with it. All of this was written in Python using some OpenAI API calls and a few other packages like FFmpeg. You'll need background in sort of general analytics, how to store, capture, and work with data, and some general software engineering, as well as a brief knowledge of LLMs, but they make it so simple nowadays that you can learn that on the fly. In the end, this project allows you to generate not only long form, but short form content, and allows you to subset and clip longer form content in order to get more value out of it. Now, why would I build this project? Well, it started back in 2017 when I had an interest in learning more about different topics and was stuck in an office cubicle and can only listen to content and couldn't read it or visually look at it. So I wanted a tool that would dictate Wikipedia articles. 2017, LLMs weren't around. This was brand new technology. I was very new to programming, so I was able to teach myself how to build videos like this.
Superhero appearing in American comic books, published by Marvel Comics, as well as its associated media. The character...
As you can see, it's not the prettiest. It works, it's functional, but it's just scrolling text across the screen, and the voice is pretty poor. Nowadays we have better tools, I'm a better programmer, and we're able to produce content like this.
Advantages of radiation concerns and regulatory hurdles made these units obsolete. Sometimes alpha part, or in a particle strontium titan systems, MEMS. Nuclear engineers at the University for nuclear safety and security have all been compromised at the site. Radiation and other accidents and incidents. Sure,
it's kind of generic. It's not that spicy. I'm truly taking just the text from Wikipedia that's related to these articles and asking text-to-speech to process this. But it's a great project to learn from. There is a valid business case for this. Not anymore, I might caveat. YouTube is no longer allowing the monetization of these AI-generated channels, which I don't have a major problem with. This project was a fun project to work on, with a slight opportunity for it to be a business. And for context, this was built back in November 2024, so things have absolutely changed now. But to generate a long-form video, I was able to estimate, depending on the article length, a cost of about $1 to $4.50 to generate all of the images, text-to-speech, as well as the metadata via API calls, as well as a small percent of energy cost. You can see most of the cost is actually from image generation. I'm then able to convert that long-form content into clipped content for around 3 cents, with most of that cost being metadata, as well as just a tiny amount of electricity. And lastly, shorts take about 26 cents per video, as I'm subsetting the images from the longer form content. The longer form content became the anchor of this project, and I'm able to subset and utilize that content to create short form content. And as for payoff goes, you can see that on the long form content, I only needed around 350 to 900 views, assuming my channel was monetized, in order to pay back on a $5 CPM, and I need about 5,000 short views to pay back on a 5-cent CPM. Fairly attainable. As you can see, you can churn out a ton of content with this very quickly. It doesn't take too long to generate a video, probably I would say maybe 15-20 minutes. Your bottleneck becomes the OpenAI image generation API calls. I got rate limited. My account's not big enough to get additional calls per hour. But if you had a bigger account, you could absolutely do that. Now I want to get into how this actually works and talk about the different components and different areas of opportunity to learn while building out a project like this. You'll see on the screen is a slide deck that has various information about this project, but you're looking at the different project components that go into this. The first part about this project is you need an article sourcer. You need a content sourcing mechanism. For me, I chose for that to be Wikipedia articles. I'm sourcing that directly in Python. Wikipedia is a free open access space to grab content from, so it felt safe. It also has all the information you could possibly want in the world, so if there's a topic you're interested in, you can gather that information. Now the hard part becomes, what topics are you sourcing? There's thousands of articles to be had. That's where I went and found out that there's a website that actually tracks the top 100 articles from the prior day. So I go in every day, I source that list of top 100. I'm verifying if I've already produced an article. Certain people, as you can imagine, Donald Trump, JD Vance, like any of these huge names, LeBron James, they're going to be picked up on a regular basis and be a part of that top 100. So you have to make sure you're not recreating those same videos based on that Wikipedia article. That information, the processing log was then generated and stored in a Parquet file. You can choose a CSV or whatever you'd like. You could even create a database here if you wanted to test your skills in this space. But that becomes the backbone and spine to orchestrate what we're creating. This eventually evolves into a larger file with timestamps for each of the processing dates as well as stages that we're going to be progressing towards in this project. The next phase is the audio generation. So we're taking the text from the article. I'm passing that up into OpenAI, into their text-to-speech option. I did try some other options, but as far as being able to quickly iterate and get a product, OpenAI's API service is fantastic for these style of projects. And I was able to dump a couple $100 in credits in and generate hundreds of videos. And you could easily get this done with the $30 or $20. OpenAI makes it very easy to add a set amount of credits into the system, and that way you don't feel like you could get dinged on the back end if you accidentally left the project running or you had bugs in your code. The next phase of the project is image generation. So in order to tackle this, you can't pass the entire article up every single time, and you also want images that are relative to the section that you're talking about at that period of time. So what you do is you take in sort of the metadata of the article, the person, maybe some small context on who the person is or topic that you're talking about. And I was then taking chunks of text based on where I'm at. So I'm iterating through the larger text in chunks of about 600 characters and passing that up into the LLM prompt, asking it to create an image that corresponds with what I'm saying. That allows for the image to change and be relevant with the different phases of the article, allowing for or giving the user some intrigue as they progress and watch the video. Video creation is handled entirely by FFmpeg. FFmpeg is a library that is fantastic in Python. You can do a lot of manipulation of images and videos. So I'm taking all of those images generated from the prior prompts. I'm also taking that text you saw previously. I'm editing the video slightly. As you'll notice, some of the videos have a shift in panning or shift and zoom sort of flow to them to give some more intrigue to the video. And I'm stringing all of this together in Python. This processing takes only a few minutes. And I will admit though, this part took a significant amount of debugging as there's a lot of nuance and library dependency that happens here that honestly is a bit over my head, but if you're diligent and persistent, you can solve those bugs. The next step is metadata creation. So this is your YouTube video title, your tags, your description. as well as any other information that you would need as part of the YouTube upload process. All of these are API calls to OpenAI, passing in necessary information in order to generate the required content. For example, the title would get maybe the first 500 characters of the text, and I'd ask to generate a title based on that. The tags, on the other hand, I would include a larger body of information and ask to generate tags and be very specific in prompting and asking for a comma-separated list to upload into YouTube. The last piece is thumbnail creation. So thumbnail, the text on the thumbnail itself is a part of that metadata creation phase. And I'm also selecting one of the images that was generated at step 4 in this process. That way I can string the two together. The final step, of course, is uploading this into YouTube. So there's different API calls that you can write that allow you to directly insert this information and upload it to YouTube. I will note this is not something I built originally. When I first started this project, I was manually uploading it. But as you can see, I was able to generate hundreds of videos and it became very time consuming. And it was fairly easy to automate using a couple packages that exist, as well as a couple Google searches. As for YouTube clip creation, I'm taking the larger post-uploaded video, I'm calling the YouTube API and returning text alongside timestamps. This is an important data set that you need in order to create chapters. And then passing that timestamp and text coincided subtitles data set into an LLM and asking it to create chapters, YouTube chapters, to help organize the information. This then gets added to the initial YouTube video itself, but then it's also used later to take over, I believe it's 7 minutes of clip time, of time span, and clip those out as individual components. That way I can upload them separately and additionally gain more video views without having to generate additional images, which is the largest cost in this process. As for short production, I'm using a similar process, but I've created what people would commonly refer to as agents, which I don't like that term, but I have bots designed to be script writers, short script writers. I've refined the prompt over the iterations of this project to create different types of stories with the information it's passed in. So I'm passing in the Wikipedia article information in different chapters at a time, and I'm asking it to craft a short style video based on the information passed in different formats that include did you know, aka surprising truths. As for a tech overview, the core code base is all written in Python. We're using generative AI tools. I exclusively, I should say, used OpenAI in production. I absolutely did test some of the other models and ended up going with OpenAI due to their simplicity. Image generation was done with DALL-E 3. Again, this was built in November 2024, so a bit older. And I used OpenAI's text-to-speech, which is available. I did utilize coding assistants like GitHub Copilot. And I also really utilized the web interfaces too for OpenAI, Gemini, as well as Claude to help further resolve some of my issues. I want to share some learnings that I had from this project that I think will be applicable to others. And that's the idea that vibe coding really did speed up this project. As I mentioned before, back in 2017, without LLMs, I was able to build a version of this. That took me months to build as an after-work project. This took me a couple weeks to build, and it's a lot more robust and a lot better written. But I'm absolutely trading off some of my understanding of code when you vibe code. That's just how it works. Anyone who vibe codes or anyone who codes for a living will know that tech debt and understanding of code is far more valuable sometimes than the actual generation of code. And you'll have to spend more time debugging in the end. But for someone like me, who's an analytics professional, I write Python and SQL for a living. I'm not a software engineer though, and this allowed me to do some software engineering type tasks. On that note, I operated as more of a technical project manager with this, so I absolutely wrote a bunch of Python code for this, but I spent more time scoping out what I needed, the different components, how things would interact. That's where most of my time was. I used the LLMs to bounce ideas off of, talk about what approaches I should use, and generate code. which was a lesser amount of time than the actual project planning as well as debugging. Now, I do want to note I still absolutely needed to know how to code, or at least debug the project. I would not have finished this project without that knowledge. My other two takeaways are this helped me level up a band, I'd say. So I went from being sort of, I'm really strong in analytics and that type of coding framework. I'm mediocre, if not novice, at software engineering style coding, and that leveled me up to be a lot more competent. So it's only giving me one little bump. It's not changing who I am. And LLMs in general help the most when you are breaking ground on something. I don't think this is revolutionary to say now, but if you're just starting out on something, LLMs are incredible for that, and they help to break the ice, and that is extremely valuable. But if you already know what you're doing, you might be better off just writing it yourself. I also want to talk about some techniques that I picked up that I think would be valuable. I love talking to my LLM. I have a microphone on my headset, and I am listening to music, talking to my LLM, and working out my coding problems, as well as just brainstorming on how to approach different problems in the project. I also found a lot of success in ensembling with using the different LLMs to solve problems. As I mentioned, I ran into major issues with the FFmpeg processing of the videos. If you don't have the settings just right, it'll take forever to encode the video. But due to an ensembling of Claude and Gemini and OpenAI, and sort of bouncing around the three of them, I was able to find a solution for something that I just would not have been able to figure out on my own. I think it's also very important to break your tasks into the simplest possible task. LLMs are not the greatest when you give it a lot at once. Chunk it, really plan out your project, and try to approach it step by step and modularize your code. I really appreciate you guys watching. This is a demo and sort of overview of this project. If you guys enjoy it, let me know, and I'm happy to dive more into the actual code. Let me know which section you're most interested in. Appreciate you guys' time. Thank you guys for watching.